Good morning, grade 8 learners. Welcome to our Valenzuela Live in Mathematics 8 for week 8. I am your live streaming teacher for today, Sir Romeo Emiclat, from the Valenzuela City School of Mathematics and Science, grade 8 Enhanced Mathematics teacher. Join me as we discuss and learn mathematics today. So, I want you to listen attentively, focus on our discussion, engage in every activity throughout our lesson, and of course, have fun. Our topic for today is about probability of simple event. Specifically, we will learn to find the probability of a simple event. The learning competencies we are going to cover for today is to find the probability of the simple event. In our everyday life, there are a lot of situations where probability should be considered. The probability of an event is the likelihood of its occurring. When we discuss the likelihood of an event happening in everyday life, we may use some common words to describe this likelihood. For example, certain, likely, very unlikely, or impossible. For the recall, I have here some situational probabilities happening in our surroundings. I want you to do something for me. Please choose the appropriate emojis for the following situations. I will give you ample time to decide which one is correct. Let us try the first one. How many possible outcomes are there when you roll a die and flip a coin at the same time? Like emoji 12, heart emoji 8. Timer starts now. Time is up. The correct answer is the like emoji. There are 6 possible outcomes when you roll a die and 2 possible outcomes when you flip a coin. Therefore, by multiplication principle of counting, there are 6 times 2 is equal to 12 possible outcomes when a die is rolled and a coin is flipped at the same time. Let's try the next one. Matthew wants to set a screen lock on his phone. He was asked to give a 6-digit PIN code. How many possible codes are there if digits are drawn from 0 to 9? Like emoji 1 million, heart emoji 100,000. Timer starts now. Okay, time is up. The correct answer is 1 million. There are 10 digits to choose from for each digit of the PIN code. Therefore, by multiplication principle of counting, there are 10 times 10, times 10, times 10, times 10, times 10, or 10 raised to 6, which is equal to 1 million ways. Next, Ayaka wants to play Roblox, an online game platform. To start, she needs to create her avatar. If an avatar is composed by a head type, a face type, a body type, and a set of clothing, if there are 4 different head types, 8 different face types, 5 different body types, and 12 different sets of clothing, what is the total number of avatars she can randomly generate? Like emoji 2160, heart emoji 1920. The timer starts now. Okay, time is up. The correct answer is the heart emoji. By multiplication principle of counting, randomly, there are 4 times 8 times 5 times 12, which is equal to 1920 ways to generate an avatar. For the last problem, Dr. Strange had this incredible power to travel across the multiverse and possibly meet other versions of himself. In one of his travels, he met Dr. Strange, from Earth 729 and told him that the universe is not infinite. In fact, the total number of universes is the same as the number of plate numbers that can be made from 3 letters and 4 digits. If this is true, how many universes are there? Letters are from the English alphabet and digits are from 0 to 9. Heart emoji and like emoji. And the timer starts now. Okay, time is up. The correct answer is the heart emoji. There are 26 times 26 times 26 times 10 times 10 times 10 times 10 ways for the plate numbers to be made. Therefore, there are 175,760,000 universes that exist. One of the biggest, if not the most epic marvel, Doctor Strange in the Multiverse of Madness, is now widely shown in cinemas all over the country. Aki is one of the thousands who wish to see this feature film. Where should he watch this movie? He can choose among 6 local cinemas of Valenzuela City and nearby city. SM Marilao, Cinema 1 and 2, SM Valenzuela, Cinema 1 and 2, One Mall Valenzuela, Cinema 1 and 2. How will he pick from the choices? He then thought of using a die with 6 faces, assigning a cinema in each of the die face. He'll throw the dice and whatever cinema will be facing upwards will be his choice. What is the chance that he will choose a cinema from Valenzuela City? When you hear the word chance, predicting, possibility, we are referring to probability. Today, we will talk about the theoretical probability of an event. Theoretical probability of an event is the ratio of the number of favorable outcomes to the total number of possible outcomes. The probability of an event is equal to the number of elements all over the number of elements in the sample space. In symbol, P of E is equal to the cardinality of E divided by the cardinality of S. The probability of an event ranges from 0 to 1 inclusive. A probability of 0 means that an event has no chance of happening or it is impossible. For example, it is not possible to get a 7 from a normal 6-sided die. Therefore, its probability is 0. On the other hand, an event with a probability of equal to 1 means it is guaranteed to happen. An example of this would be the probability of electing exactly one president in the Philippine national elections. Let us say we have an experiment of rolling a die. The sample space is 1, 2, 3, 4, 5, 6. N of S is 6. Event is an even number is on the top of a die. Our E is 2, 4, 6. N of E is 3. Substituting to our formula, then the probability of an event is equal to 3 over 6, which is also equal to 1/2. To continue our lesson, I have here some situational probabilities. I wanted to choose the appropriate emoji for the following situations. I will give you ample time to decide which one is correct. Let us try the first one. Identify the sample space when 2 coins are tossed using the tree diagram. The diagrams are given below. Choose like emoji or heart emoji. The timer starts now. Okay, time is up. The correct answer is the heart emoji. The sample space is the set containing HH, HT, TH, TT. Let us have the next one. In tossing two coins, what is the probability of getting both heads? Like emoji, 1/4. Heart emoji, 1/2. The timer starts now. Okay, time is up. The correct answer is 1/4. The event is the set containing HH. Number of event is 1. The number of sample space is 4. So the probability of the event HH is 1/4. Next one, in tossing two coins, what is the probability of getting both tails? Like emoji, 1/2, and the heart emoji is 1/4. The timer starts now. Okay, time is up. The correct answer is 1/4. The event is the set containing TT. Number of event is 1. The number of sample space is 4. So the probability of the event TT is 1/4. Next problem. In tossing two coins, what is the probability of getting one head and one tail? The like emoji is 1/2 and the heart emoji is 1/4. The timer starts now. Okay, time is up. The correct answer is 1/2. The event containing a head and a tail, which can be HT and TH. The number of event is 2. The number of sample space is 4. So the probability of the event 1H and 1T is 2/4 or 1/2. If a pair of dice is rolled, find the probability that the same number is on the two faces. Below is the table of elements in the sample space. The like emoji is 5/36. The heart emoji is 1/6. The timer starts now. Okay, time is up. The correct answer is 1/6. First, let us construct a table to determine the sample space in rolling a pair of dice. In here, it shows by the shaded part are the elements where the same number is on the two faces. And here are the set of the sample space. The element of event A that the same number is on the two faces are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A is equal to the number of event divided by the number of sample space. The number of event is 6. The number of sample space is 36. So substituting to our formula, the probability of event A is equal to 6/36, which is also equal to 1/6. Another problem, if a pair of dice is rolled, find the probability that the sum on the two faces is at least 11. Below is the table of elements in the sample space. Like emoji is 1/12. The heart emoji is 1/11. The timer starts now. Okay, time is up. The correct answer is 1/12. First, let us construct a table to determine the sample space in rolling a pair of dice. Here, it shows by the shaded part are the elements where the sum of two faces is at least 11. The element of event B is that the sum of the two faces is at least 11 are 5, 6, 6, 5, and 6, 6. Then the probability of event B is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event B is equal to the number of event divided by the number of sample space. The number of event is 3. The number of sample space is 36. So substituting to our formula, the probability of event B is equal to 3/36, which is also equal to 1/12. Okay, if you pick a card from a standard deck of cards, which has 52 cards and no jokers, find the probability of picking a face card, king, queen, or a jack. The picture below shows a 52 card deck, which is typically consists of 4 suits, hearts, diamonds, spades, and clubs. Each suit contains 13 cards, 10 numbered cards from A to 10, and 3 face cards, jack, queen, and king. Hearts and diamonds are red suits, while clubs and spades are black suits. The like emoji is 3/13, and the heart emoji is 4/13. The timer starts now. Okay, time is up. The correct answer is 3/13. Here is the sample space of the deck of cards. The element of A, which is the face cards, are king of spade, king of clubs, king of diamonds, king of hearts, queen of spade, queen of clubs, queen of diamonds, queen of hearts, jack of spade, jack of clubs, jack of diamonds, and jack of hearts. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A is equal to the number of event divided by the number of sample space. The number of event is 12. The number of sample space is 52. So substituting to our formula, the probability of event A is equal to 12/52, which is also equal to 3/13. Another problem, if you pick a card from a standard deck of cards, which has 52 cards with no jokers, find the probability of getting a nut, an ace. The picture below shows a 52 card deck. Like emoji is 12/13. The heart emoji is 51/52. The timer starts now. Time is up. The correct answer is 12/13. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A is equal to the number of event divided by the number of sample space. The number of event is 48. The number of sample space is 52. Substituting to the formula, the final answer is 12/13. Okay, example 3C. If you pick a card from a standard deck of cards with 52 cards with no jokers, find the probability of getting a red face card. Like emoji is 3/26 and the heart emoji is 2/13. Timer starts now. Okay, time is up. The correct answer is 3/26. The elements of event A are king of diamonds, king of hearts, Queen of diamonds, queen of hearts, jack of diamonds, and jack of hearts. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A is equal to the number of event divided by the number of sample space. The number of event is 6 and the number of sample space is 52. Substituting to our formula, the event A is equal to 6 over 52, which is also equal to 3 over 26. Example 3D. If two cards are drawn one at a time without replacement, what is the probability that both are ace cards? Like emoji is 1 over 221. Heart emoji is 4 over 663. The timer starts now. Time is up. The correct answer is 1 over 221. By multiplication counting principle, the number of sample space is equal to 52. The first draw, there are 52 possibilities times 51. After we picked one, there are now 51 possibilities or choices, which is equal to 2,652 because based on the problem, there is no replacement. To get the number of elements in event A, we have 4. There are 4 ace cards for the first draw times 3, which is 3 ace cards that remains after the draw, which is equal to 12. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A is equal to the number of event divided by the number of sample space. The number of event is 12. The number of sample space is 2,652. Substituting to our formula, our answer is 1 over 221. Now, it's about time for you to try the following. I have here some situational possibilities. I want you to choose the appropriate emojis for the following situations. I will give you ample time to decide which one is correct. Let us try the first one. Morty is sick and cannot go to school. He did not want to be marked as absent for the day, so he asked his grandpa, Rick, if he can help him. Rick built him a robot, Morty, that will go to school in his stead. Coincidentally, they have a multiple choice quiz in math, and unfortunately, Robot Morty is not capable of answering. As a result, Robot Morty answered randomly. Situation A, if there are 10 items with 10 points, each with no partial points given, which set contains all of his possible scores? Like emoji and the heart emoji. The timer starts now. Okay, time is up. The correct answer is the like emoji. If he will not get any correct answer, he will get 0. If he will get 1 correct answer, then he will get 10 points, since there is 10 points for each correct answer. If 2 correct answers, he will get 20 points, and so on. And if he get 10 correct answers, he will get 100 points, which is the perfect score. Okay, after finishing the quiz, Morty's math teacher told Robot Morty that he got a prime number of questions correctly. Which of the following correctly contains all his possible scores. Like emoji, 10, 20, 30, 40. Heart emoji, 20, 30, 50, 70. Timer starts now. Time is up. The correct answer is the like emoji. Prime numbers include 2, 3, 5, and 7. Therefore, his possible scores are 10, 20, 30, and 40. Since each question is 10 points, if he gets 2, his score is 10. If he gets 2 and 3, or 2 and 5, or 2 and 7, his score is 20 points. And so on and so forth. Our problem number 2 came from our Filipino subject. Ito ay mula sa Florante at Laura, mula sa unang kabanata. And here is the situation. Mula sa unang kabanata ng Florante at Laura na may pamagat na ang gubat, may 4 na mababangis na hayop na gumagala. Ito ay ang siyerpe, ang hyena, ang leon at ang tigre. Sa gubat na ito matatagpuan ang kaawa-awang si Florante na nakagapos sa ilalim ng punong higera. Ang salarin sa pagkagapos niya dito ay ang mapag-imbot na si Conde Adolfo. Question: what is the probability that the lion almost attacked Florante? Like emoji, 1/2. Heart emoji, 1/4. Timer starts now. Okay, time is up. The correct answer is 1/4. The number of sample space is 4, which is the siyerpe, hyena, leon, at ang tigre. The number of event is 1. Ito yung leon because there is only one lion which almost attacked Florante. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of the event A is equal to the number of event divided by the number of sample space. And substituting to our formula, with n of A is equal to 1 and n of S is equal to 4, the final answer is 1/4. Hindi nagtagumpay ang leon sapagkat dumating si Aladdin at iniligtas niya si Florante. Remember, in your science subject is the Punnett square. But first, what is a Punnett square? A Punnett square is a graphical representation of the possible genotypes of an offspring arising from a particular cross or breeding event. And here is our problem. A wolf with a homozygous dominant trait, brown eyes, mates with another wolf with a heterozygous trait, brown eyes. What is the probability that they will produce a wolf with brown eyes? The Punnett square is given below, where capital B representing the brown eyes, which is the dominant allele. The small b represents the blue eyes, which is the recessive allele. Homozygous dominant is capital B, capital B. The heterozygous is capital B and small b. The homozygous recessive is small b, small b. Like emoji, 1 or 100%. And the heart emoji is 1/2 or 50%. The timer starts now. Okay, time is up. The correct answer is 1 or 100%, the like emoji. The number of sample space is 4 with elements capital B, capital B, capital B, capital B, capital B, small b, capital B, small b. The number of event is 4, which is the brown eyes. Then the probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. the probability of event A is equal to the number of event divided by the number of sample space. So substituting to our formula, the probability of event A, which is the brown eyes, is equal to 4 over 4, which also equal to 1 or 100%. As you have noticed, in the sample space, each element contains capital letter B for the brown eyes. Problem number 4. A box contains 10 white balls, 21 yellow balls, and 14 black balls. Ross then randomly pick a ball. What is the probability that Ross do not get a yellow ball? Like emoji is 7 over 15. Heart emoji is 8 over 15. Timer starts now. Okay, time is up. The correct answer is 8 over 15. The probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of event A, which is equal to the number of events divided by the number of sample space. So, substituting to our formula, the probability of event A, which has 10 white balls and 14 black balls, divided by 10 white balls, 14 black balls, and 21 yellow balls, is equal to 24 over 45, which is also equal to 8 over 15. Okay, in a multiple choice exam of 5 questions with 4 choices each, what is the probability that the student wrote D in all items? Like emoji 1/4, the heart emoji is 1 over 1024. The timer starts now. Okay, time is up. The correct answer is 1 over 1024. The number of sample space is 4 times 4 times 4 times 4 times 4, which is equal to 1024. The number of event is 1, which is the capital D, capital D, capital D, capital D. The probability of event A is equal to the number of favorable outcomes divided by the total possible number of outcomes. The probability of A is equal to the number of event divided by the number of sample space. So substituting to our formula, the final answer is 1 over 1024. Next problem, what is the probability that a letter randomly chosen from the word counting can also be found in the word mathematics? Like emoji 3 over 8, heart emoji 5 over 8. The timer starts now. Okay, time is up. The correct answer is 3 over 8. C, T, and I are the only letters that can be found both counting and mathematics. Thus, the probability of such event is 3 over 8. Now it's time to summarize everything by stating all the important points we need to remember. Theoretical probability of an event. It is the ratio of the number of desired or favorable outcomes to the total number of possible outcomes. In symbols, the probability of event A is the cardinality of the event E divided by the cardinality of sample space S. The range of values of the probability of an event is from 0 to 1 inclusive. Now it is time for you to voice out all your questions by typing it on our comment box. Sige, let's wait for the question. Okay, meron tayong isang question dito. Paano po malalaman kung ang nakuha mong probability ay tama? That's a very good question. There are two ways. The first one is the value that you have obtained must not be less than 0 nor greater than 1. And the second way is when you list down the elements in an event or in sample space, the same number must be obtained when you use the fundamental counting principle. Any other question or concern? Okay, since we don't have any other questions, I want to give you homework so that you can practice our lesson for today. Okay, this is our homework. Probability is an integral part of our everyday life. Knowing that something is possible to happen will surely give us that feeling of hope, a feeling of chance. Mathematics may state these things in numerical statements, but its application traverses our emotions and spirits. The fact that probabilities do exist will influence us to strive harder and be better. Again, this is Sir Romeo Emiclat from the Valenzuela City School of Mathematics and Science saying, life will always be like a roulette, though chances may be small sometimes, but that chance represents success that we should always hold on and continue to work hard on its realization. In life, the more acts of kindness you bestow on your fellow men, the greater the chances of you attracting blessings and success in the future. God bless you.